Okay, so welcome to this video. So we'll be doing social network analysis. Now, because of power, this video will be made in parts. So this is part one. So we'll be doing the 2024 sessional examination paper, cybersecurity. Yeah, so the course is social network analysis, course code CYS211. So the time for this paper was just 3 hours, okay? So we won't go through these instructions, but it's necessary for you to do so when you're writing an exam, okay? So we are starting off with question 1, which is compulsory because they're saying section A answer both questions. So we have question 1 and question 2, which is compulsory. Okay, so using the figure given below, so which is this figure, draw the social matrix represented by the above figure. So I'll be assuming that we don't have a clue about what's happening, so I'll be explaining everything in detail, okay? So the first thing they're telling us that we are given this figure, okay? So what is this? So first of all, we need to understand that here we have actors and lives near, okay? So actors in social network analysis, they can be denoted as a node, okay? Nodes or points. So these are just people who are involved in a social network analysis, okay? So in this case, we have Alison, Drew, Elliot, Kate, Rose, and Sarah who are involved in this particular social network. So what's a social network? So a social network is just more like a community of people having different relations among themselves, okay? We can give an example. This lives near is a relation, showing the relation between a certain actor. For example, Alison, who is our first actor denoted by N1, as a relation with Rose and Sarah, who happens to be N5 and N6. So in this case, we can take note that a social network is simply a relation that exists among different actors or actors, okay? So that's what we mean. Now, since we have an idea of this figure which we are given, we need to understand that the first question says draw the social matrix represented by the above figure, okay? So now, what's a social matrix? So you understand the term social, it has to do with interaction. Now, matrix, it's something which deals with quantities in mathematics, okay? We have different numbers and those numbers can be represented in a row by column format, which forms a matrix. So that concept will be taken from mathematics, then we are going to apply it here, okay? So first of all, we need to understand that a matrix has what we call rows and columns. So we need to identify how many actors do we have. In this case, we have 1, 2, 3, 4, 5, 6. So we have 6 actors which can be represented in a 6 by 6 row and column to represent this social matrix so that we understand their relation, okay? So we are going to start off with that. So we'll start right one. So let me just pause the video so that we don't waste. Okay, so now what I was saying is that we need to come up with 6 rows and 6 columns. Remember, our nodes or actors are denoted by N1, N2, N3, N4, N5, N6. So these will be displayed in our row and in our column. So let me just zoom in properly so that we get to do the work here, okay, nicely. So as you can see here on the boxes, we can represent these nodes with their denotation. So we have N1, we have actor who is N2, okay? Then just let me, okay, so we have these 1, 2, 3, 4, 5, 6 nodes represented in our row, okay? So these nodes are representing those actors. So n stand for node, then 1 is the position number, so node 1. So node 1 in this case represents Alison. Okay, represents Alison. N1 is Alison. So we want now to indicate these same labels which are from N1 to N6 onto our columns. So let me just pause the video and do that. Okay, now since we are saying it's a social matrix, okay, we want to represent their relation in this 6 by 6 matrix. Why is it 6 by 6? We have 6 nodes on the rows, then 6 nodes to our column. Okay, so it's a 6 by 6 matrix. So now to represent this, we need to take note of two important things. Okay, so here we are saying we need to take note of two important things. So what are those? So number one, if a relation exists, we'll be denoting it with a 1. So let me just write that. Okay, so what we mean is that if a node happens to have a relation with another node, we'll be denoting that with a 1. So if a relation exists, we'll be saying 1. If no tie or relation exists, so a tie we are simply meaning a relation or a connection. If no tie or relation exists, we are going to say 0. So let's put this into practice and we start doing our work. Okay, so let's take for example, here we have N1 who happens to be Alison. So Alison has a relation with Rose and Sarah. Then Rose is node N5 and Sarah is node N6. So since N1, let me just do this so that it becomes clear. So N1 has a relation with node N5 and N6. So we've indicated those with ones because we are saying this actor happens to have a relation with this guy and that guy, N5 and N6. So because it doesn't have any relation with N1, N2, and N3 and N4, we are going to represent that with zeros. Now remember, N1 and N1 is the same node, so this tie or relation will never exist. Same applies with N2 and N2, this tie will never exist. Same applies with N3 and N3, again we indicate a 0. So now we know we have N4 and N4, here we put a 0. We have N5 and N5, again we put a 0. Then we have N6 and N6, again we put a 0. Why? Because this tie will never exist, okay? Because you cannot have a relation with yourself. For example, I have a relation with myself. That's abnormal, okay? It's not possible. So now, coming to the next node, who is N2. So N2 happens to be Drew as a relation with Elliot, who is N3. So N2 has a relation with N3, okay? We are going to say N2 has a relation with N3, that's all. So here we are going to put zeros because we haven't seen any relation. So as simple as that, we are now analyzing this thing. So let's just try to be quick because we understand what we are doing. So coming to N3, who is Elliot, happens to have a relation with Drew. Now, since N3 happens to have a relation with Drew, who is N2, we are going to come to N3, then we are going to put a 1 where there is N3 as a relation with N2. The rest are zeros. Now, take one important thing straight here. If a node happens to have a relation, for example, N2 has a relation with N3, okay? N2 has a relation with N3. Again, we're saying N3 has a relation with N2. It means these two nodes chose themselves, okay? Their choice, it's more like I choose you, again, the other guy chooses me. So that decision is what we indicate with an edge. So an edge is just a line which has no direction, okay? So this line which has no direction is called an edge, and it indicates that actors made the choice of choosing themselves. So that relation is represented by a line which is called the edge. Okay, so now we are breaking these things down, because this is when we are starting talking about these particular tutorials for social network analysis. But keep in mind, we had the 2024 CYS online tutorial classes, and I've covered the C++ programming for social network analysis. So it's important that you access those materials. It will be attached as a playlist at the end of this video, so take note of that. Now, we have actors such as N4, who is Keith, and has a relation with Rose and Sarah. Now, Rose is N5 and N6. So we are saying N4 has a relation with N5 and N6. So sharp, we indicate that. So N4 has a relation with N5 and N6, just like the first actor did, okay? So here will be indicating zeros because no tie or relation is existing. Now come to N5, who is Rose. So Rose has a relation with Alison, who is N1, then Kate, who is N4, and Sarah, who is N6. So we are saying N5 has a relation with N1, N4, and N6. So we are going to indicate that. So N5, just a minute. So N5 has a relation with N1, N4, and N6. So here we are going to put zeros. Now remember, N1 had the relation already with N5, okay? Same applies with N5 as a relation with N1. So again, this line will be represented with an edge. Okay, so take note, because they have chosen each other. Now we come to N6, the final node. So N6 with Sarah happen to have a relation with N1, N4, and N5. So let's indicate that. So N6 has a relation with N1, N4, and N5. So here we'll put zeros as usual. Now, take note, N1 had the relation already with N6. So N6 again has a relation with N1, which becomes an edge, okay? Then N6, here we are saying it has a relation with N4, okay? Now remember, N4 had the relation with N6. Again, it becomes an edge. Here we are saying N6 has a relation with N5, but again, N5 had a relation with N6. So we can conclude that this social matrix, if we convert it into a sociogram, meaning a diagram which can show their relations by the use of arrows such as edges and arcs, this would be drawn or represented with edges, because all these nodes choose each other at a certain point. So that will be demonstrated when the time is right during the next question. So all in all, this thing which we have written is now what we call an adjacent matrix. So we call this whole thing as an adjacent matrix. Adjacent matrix. So under adjacent matrix is just a type of a social matrix whereby we just show the relation by indicating a 1 and a 0 if a relation exists or no. So if you are linked with something, that connection is adjacent to a particular thing you are linked to, okay? So that's the meaning. So now, hope this was clear. Let's jump into the next question, which is B. So B says, calculate the diameter of the graph, okay? Calculate the diameter of the graph. Show all necessary steps. First of all, we need to understand this term, diameter. So what is diameter? So in social network analysis, a diameter happens to be the longest geodesic distance. Now, we don't even understand the term geodesic distance itself. So the geodesic distance is the shortest distance in a sociogram or network. So for me to explain these two terminologies, we need to answer this question then we understand. Okay, so here we start now. So let me just zoom in so that we indicate this. Remember, here I talked about displaying this in form of a sociogram. So let me just spell sociogram for you. So we are saying social, but not the social with the A, like this, sociogram. So I defined the sociogram before, where I said it's just a graph or illustration which depicts or represents the relation among actors using directions, okay, which can be edges or arcs. Now, since I've denoted that this would be an edge already, so we know what we are doing. So let's start. We have actors such as N1 going all the way to N6. So let's represent that first. So here we have actors, as I'm saying, we have N1, okay, as our actor, okay. Again here we have N2 as our actor, then we have N3 as our actor, then we have N4 as our actor, then we have N5 as our actor, and finally we have N6 as our actor or person in this particular sociogram. So if you can take note, at first I even emphasized that we need to take note of the number of nodes we have. So we have N1 up to 6. No wonder I've said N1, N2, N3, N4, N5, N6. We want to draw this sociogram, okay? So N1 has a relation with rows. So rows is N5. So here N1 we are saying has a relation with N5. I'll represent it like that, okay? Again, we're saying Alison has a relation with Sarah, who happens to be N6, okay? So since N1 again has a relation with N6, we're going to present it like that, okay? So once we do that, we go to N2. So N2, who is Drew, has a relation with Elliot. So Elliot is N3. So N2 has a relation with this guy who is N3, okay? Now we come to N3. N3 has a relation with Drew. Now remember, since this line already exists, it becomes an edge. If it wasn't an edge, I could have shown with an arrow. Now it becomes an edge because these two particular guys choosing each other. We come to N4. N4 happens to be Kate as a relation with Rose with N5. So N4 we are saying has a relation with N5 like that. Again, we are saying N4 is Kate as a relation with Sarah, which is node N6. So N4 has a relation with N6 like that. Now we say we come to N5. N5 has a relation with Harrison, who is N1. So since N5 has a relation with N1 and this line already exists, it becomes an edge, no direction, okay? We come to N5 has a relation with Kate, okay? So Kate happens to be N4. So N5 has a relation with N4. Again, this line already exists, so it becomes an edge. Now we are saying N6, who is Sarah, has a relation with Harrison. Already this line exists, so it becomes an edge. Again, we say N6 has a relation with N4, which is Kate. So as we can see, N6 has a relation already with N4. Again, this becomes an edge because it exists. If we remember, N5 had a relation with N6 with Sarah. So this line should be here, okay? Again, we are saying this same N6 has a relation with Rose with N5. So as you can see, this line already exists, so it becomes an edge. So as I was saying, this sociogram or a diagram which represents these nodes with lines is becoming a line which has edges, okay, because it has no directions, because these people were choosing each other. So that's the meaning. Now coming back to our question, it says we need to calculate the diameter showing all the possible stages. So we need now to consider one thing here. what's a geodesic distance first. So let me write it here, saying geodesic distance. So this paper will be filled up with a lot of solutions. So let me just pause the video and write geodesic distance. Okay, so that's geodesic distance. Okay, so I was saying geodesic distance is the shortest route or path you can take in a sociogram, okay, or network. So in this case, geodesic distance is denoted by this particular formula, which is d for distance as usual, then I comma j, okay, I comma j. Now I comma j represents the first node and its relation to the second node. For example, we can only consider two nodes at once. So now we start looking at our geodesic distance. So we denote it by d, then we put a node. So let's start concentrating with n1. So we start n1, okay? We have our first node is n1. So n1, let's follow the sequence. We can have n2. So n1 has a relation with n2. So we put an equal sign. So the distance from n1 to n2, okay, what's the answer? So we want to look for the possible shortest route we can take to reach n2. So as you can see, n1 cannot reach n2. So what's the geodesic distance is 0, because we cannot reach, or we have no link to reach that particular guy with n2. So now we say d, okay, for geodesic distance, then n1 comma n2, okay. Now n3, or n3 by the way, so we are incrementing. So n2 comma n3. So n1 to reach n3, was the distance. Again, there's no link, we put a 0. So we say geodesic distance as usual. Then we are still looking at n1 till it reaches all the nodes, okay. n1 now tries to approach n4 to understand the distance, or the shortest distance it can take to reach it. So remember, n1 to reach n4 can take this route, which is 1, 2, 3. But is it the shortest one? No, because we have this route again, which is 1, 2. So the geodesic distance for this matter is 2, because that's the shortest route n1 can take to reach n4. So we cannot take this route which is 1, 2, 3, no, but this one which is 1, 2. That's the meaning, okay. Now again, we come to the geodesic distance for n1 until we approach n5, okay, since we already approached n4 till we approach n5. So what's the answer? So for n1 to approach n5, it can be either this direction, which is 1, 2, or 1. So the shortest one is this direct one, which is 1. So that's the geodesic distance. The shortest distance is 1, okay. Now we come to the last node which n1 can approach, which is n6. So we say n1 comma n6. Okay, so what's the distance there? So for n1 to reach n6, it can either take this route, which is 1, 2, or 1. So the shortest one you can see is 1. So since we are done with node n1, we come to the next node, okay. We come to the next node, which happens to be n2. So n1 we are done, so we come to n2. So n2 follows up, so we are going to start at n3, because we cannot start at n2. Just a minute, made a mistake here. Okay, so here we start at n3. So since we are targeting now n2, we want to start at n3. Remember, we're incrementing. So n2 can reach n3 just by counting 1. That's the route. So we say 1. Again, we come to the next geodesic distance. So I'm trying to waste my time as possible so that you can understand. So again, we're targeting N2, but this time around we got N4. So as you can see, not to waste much of our time here, N2 happens to have a link only with N3. So the next ones will be zeros. So let me just pause the video, because if we say N2 to approach N4, it's 0. There's no link. Again, if we say N2 to approach N5, it's 0. N2 to approach N6, it's 0. So let me just indicate that. Okay, now we come to N3, okay? So N3, we are starting at N4, okay? Since we have a node N3, so we are starting at N4. So N3 has no link with N4, we put a 0. Again, not to waste time again, we are saying N3 cannot reach N5 and N6, so those are zeros. Let me indicate that. Okay, now we come to N5, to N4, okay? So since we are targeting N4 now, we start at N5. So what's the shortest distance for N4 to approach N5? As we can see, we cannot take this route, which is 1, 2, but we can say 1, okay? So that's the route. So here we're going to say 1. But what's the geodesic distance we can take for N4 to reach N6, since we are from N5 to reach N6? As we can see, for us to reach N6, we are coming from N4, so we cannot take this route, which is the longest one, from N5 to N6, but we just go direct, which is 1. So again, here we say 1, okay? Now, since we are done with N4, we come to N6, okay? So, or we come to N5, we are done with N4. So N5, the next node is N6. So what's the route we can take for N5 to reach N6? Again, as we can see, to be 1, because N5 is directly connected to N6, so it's 1. So now the next node we are supposed to go is N6. Now N6, we don't have a node which is N7. So this is how we come up with a geodesic distance. Now I'm sure by definition you understand it. Now the question was saying we need to determine the diameter, okay? So the diameter was saying is the longest geodesic distance, okay? So in this case, we understand that geodesic distances have been found. So we need to understand the longest one. So the longest one is 2, okay? It's 2, because if we see we have zeros and ones, and the longest one is 2. So diameter is given by this formula, which is diameter. Let me just pause and write it. Okay, diameter is given with this formula, which is diameter is equals to max d open bracket I comma j closed bracket. So this stands for geodesic, okay? So diameter is equals to the max geodesic distance. So in this case, the longest geodesic distance is 2, which happens to have n1 comma n4, which is equal to 2. So we are going to replace these two letters with d, okay, with d n1 to represent I, which is the first node, and j to represent n4 as our last node, and say equal to 2, because this is our diameter, and we can see it's the longest geodesic distance based on our calculations, okay? So that's the meaning for calculate the diameter of the graph, show all the necessary steps. No wonder it's 8 marks, because if we can see, we started off with the geodesic distance, which I can say, if you know what you're doing, it's not necessary, but because of the marks, you just need to show, because you can even find the diameter just by looking, okay? But we had to go through this for you to understand. Okay, now we come to the C++ part. So write a C++ program which will be able to meet the following requirements. So again, I suggest that you start off with watching the CYS 2024 to 2025 classes for C++, where I conducted the C++ programming for social network analysis. You understand more by watching that. But again, we are going to run through these things as if we don't know what we are doing. So first step in C++, you go maybe to desktop, but this is just for the video. During an exam, you write everything on your paper, okay? But I'll take it as if you have a laptop. So you need to right click, okay, then create a folder where you want to put your stuffs. So for example, here I'll say social network analysis. I can name it social network analysis. So let me just say CYS211 because that's the course code. Okay. So once I have this folder created, I need to run a source code editor such as code blocks if I want to use code blocks or Visual Studio Code. So for this lab, let me just use Microsoft Visual Studio Code. So to understand on how to install this thing, as I have recommended, watch my playlist so that you get to understand what's happening. But here we just want to answer the question. You can still follow the video, everything will be okay. So the first thing we're going to say open folder, okay. So we're going to say open folder. So the folder is on our desktop and it's named CYS11. So CYS211. So we select that folder, okay. So inside our folder, just say yes, I trust the authors. So inside our folder, we're going to create a file, a new file, which is we can call it anything you want. So for example, let me just say it session, okay. I'll call it sessional because it was a session exam. Sessional.cpp. So .cpp is the extension for C++ programming. So once I click enter, as you can see, now I can start writing my program. So in C++, we say the first thing to do is say hashtag include, okay, hashtag include, then you say iostream, okay. Then after that, you say using namespace, so I'll explain everything. Using namespace std, so I'll explain. Then int name, just give me a few seconds, I will explain everything. Okay, so what this means is that for each and every program, you need to start with hashtag include iostream. Why? Because we want to accept both input and output for our program. Again, after that, you need to say using namespace std. Why? Because we want to allow the standard which allows code such as cin and cout or endline to be supported for our program. For now, you cannot understand, but if you watch the playlist, you understand. Just here we answer this question, okay? So each and every program should have a main function. So in this type, the data type is an integer. No wonder we are returning a 0 because 0 is also an integer. Then main is the name of this function, okay. Then now since you understand that this is our main function, let's see how now we can apply this particular program. So keep in mind that I'm trying to be fast because just watch that playlist to understand the basics. Here I'm just trying to answer the question, okay. So now this is what to do, okay. We'll say let's separate our screens so that we understand what's happening. Okay, yeah, can do that. Okay, so now here it's saying write a C++ program which will be able to meet the following requirements. Your program should first display a menu showing mini node degree and graph diameter, okay. So first of all, I need to explain to you what is this mini node degree. So first of all, we need to understand a node degree, okay. So a node degree is simply a connectivity of a node, okay. So node is node, then degree is just a connectivity. For example, let me just put an arrow to explain this. That's an arrow. Let me just zoom in so that we do everything clearly. So we start off with mean node degree, what it is, what we are looking for here. So for example, let me just wrap this. Okay, so for example, since we are talking about the mini node degree, okay, we're talking about the mini node degree here, mini node degree. So for example, we are saying it's the connectivity of the node, okay. We have nodes such as, so D, it will be representing degree. We have nodes such as N1. We have nodes such as N2, okay. So let me just pause and do. Okay, I was saying we have nodes from N1 all the way to N6, and this D this time around it's representing degree, okay. So now, since we understand this thing, we want to understand the connectivity of these nodes. No wonder we are saying nodal degree, okay. So here what we mean is that since we have this thing, okay, the sociogram, we can see that okay, let me just even use this. So we can see that N1 is only connected to how many people? 2 people, Rose and Sarah. So here I'm going to write 2. So the connectivity of N1 is only with 2 people. So Rose, Alison is only connected to Rose and Sarah, which is now the nodal degree. So Alison has a nodal degree or a connectivity of 2. We can see that N1 has 1 and 2 connections, okay. So let's try to be quick. So Drew has a connection with 1 actor. So here we say 1. Again, Elliot has a connection with 1 actor. Here we say 1. Kate has a connection with 2 actors. Here we say 2. Rose has a connection with 3 actors. Here we say 3. Okay. Sarah has a connection with 3 actors, and here we say 3. So by definition, we are saying a nodal degree is simply the connectivity of these actors. How many actors are you connected to? That's the nodal degree. Now we have this term which is mean nodal degree. So mean in mathematics stands for average, okay. Or I can say if you have 3 things, okay. For example, 1, 2, and 3. We have 3 things. If I add 1 plus 2, we have an answer which is 3, plus 3 which is 6. And how many things in total do we have? 3. So 6 divided by 3, we are getting 2. So that's the mean. So mean is more like an average of something, the medium, okay, something in between. So that's what we mean. So we want to understand the average of this connectivity for these particular nodes. That's the mini nodal degree. So we are lucky we have a formula for mini nodal degree, which is denoted by D bar to represent mini nodal degree, and we say it's equal to 2L over G. Okay, now this L you are seeing is representing lines. So now let's talk about lines. So in this sociogram, we can see that we have lines, okay. So if we count the lines we have, let me just change the color. If we count the lines we have line number 1, okay. We have line number 2, okay. We have line number 3, okay. Then we have line number 4, line number 5, and lastly this line which is line number 6. So this L represents the number of lines in this sociogram. So in this case we have how many lines? We have 6 lines. So this L will be represented with a 6 in our case. Then we have G. So G stands for graph nodes. So how many nodes do we have on this graph? We have 6 nodes. So this G would also be represented with a 6. Now to calculate this, we are saying 2 times 6, which is giving us 12. Then we have divide by sign, okay, division. So we have a 6. So 12 divided by 6, which we are getting 2. Okay, so we are saying the average or the mean nodal connectivity is equal to 2. That's the meaning for mean nodal degree. Now we want to apply these things in C++. No wonder I'm trying to explain what's mean.degree before we go to C++, and they are saying and graph diameter. So for diameter, we already know what's happening, so there's no need for me to explain. So again, we separate our screens, we start. Okay. Okay, so I'm trying to zoom out. Okay, so everything is clear now. So we are saying your program should first display a menu showing mean.degree and graph diameter. So remember, you can create a menu in C++. So if you come in this main function, now let me just say, give a comment. So double slash is a single line comment. We'll say menu, okay? So here we are trying to, this is just a comment saying that I'm creating a menu, okay? So a menu can be created. So let me just use a do while. So the syntax of a do while is do, okay, do, then these two symbols, okay? Then at the end we say wow, which has this syntax. So let me explain what's happening here. So a do while will enable us, okay, will enable us to operate something in between the do. Then if something is true, we are going to say wow, certain condition is true. So again, if you truly want to understand these things, go and watch the playlist at the end, but I'll explain everything clearly. So for us to create a menu, we need to have a choice, okay? So in this case, we're going to have a choice. So for example, you can tell the user that press 1 to see the mean.degree, press 2 to see the graph diameter, press 3 to exit the program, okay? So those choices are numbers. So we'll say int representing numbers, integers, okay? We're going to say choice. So because we want our choice to be an integer, to be accepting numbers such as 1, 2, 3, as I've said, one day I say int choice, okay? Now this do while will enable us to create that particular choice. So now what we'll be saying inside this particular operation, we need to make sure that we have a statement printing out this choice. So to print out something in C++, we say cout, then these two symbols for cout, then we give a comment by saying, for example, press 1 to calculate the mean nodal degree, okay? Then I need to end my line, okay? End line, okay? So I'll say end line because this line is done. Again, I can give another statement. I'll print out another statement which says press 2, okay? I'll say press 2 to calculate the diameter of the graph, okay? Following the question. Then again, I need to end my line. Then I'll say cout to print another statement. I can say press 3 to exit the program, okay? Press 3 to exit the program. So again, I will say end line, I end my line. So now each and every choice we are making is linked to this choice. So I'm going to say cin, which is a console input. I'm going to accept all this input which a user can make into this variable which is called choice, because whatever choice will be made by user needs to be saved in this variable called choice. Now remember, we are saying press 3 to exit the program. So during the while, we are saying if a user presses this particular condition, we need to end the program. So here we'll say while choice is not equal to 3. So what this particular thing means is that if this choice, okay, is not equal to 3, so exclamation mark and the equal sign represent not equal to. So if this choice is not equal to 3, what should happen? Because we are saying wow. So what this program means is that if a user presses 3, this process will terminate, meaning the program will end. And we are saying to exit, press 3, okay? So this is the meaning. Now, since we've answered the first question, which says your program should first display the menu showing the mean nodal degree and diameter, here we are done, okay? Now we come to question B, which says the two menu options should be implemented as functions, okay? Now what's a function? More like in mathematics, a function, you are given something to solve, okay? You are given a formula, that's the function. So use that particular function to solve a particular thing. In this case, we have a formula for mean nodal degree and we have a formula for diameter. So let's implement that. So in C++, a function can be either implemented in between using namespace std and the int main, or after the main function. So in this case, let's just implement it here, okay? So I'm going to say function or functions. So I'm going to say functions. So here, that's where we are going to put our functions. So the first thing we have is the mean nodal degree, okay? So the mean nodal degree, since it's accepting numbers, as you can see, 6 is a number, so we are going to say int. So the type of this particular function is an integer. So what's the name of this particular function? We are saying it's mean nodal degree. So that's the name for this particular function. Now, each and every function should have closed and open brackets to put certain conditions. So now, inside this function, remember, we are saying we have letters such as L. Okay, so we're going to say int L. Why? Because this L accepts lines and it's an integer such as 6, okay? Then comma, we have another variable or letter which is G. So we're going to say int G to represent graph nodes, which can be an integer or letters. So once we do that, we're going to come out of the brackets, then say open and close the curly braces. So inside this, we're going to insert our formula. So our formula is straightforward. We are saying d bar is equal to this. So I'm going to say int, because it's accepting numbers to be our output such as 2. I'm going to say int d is equal to, just as you can see, 2, okay? So we put 2, then this 2L, it's times L, okay? So times in C++, we say star. Then L represent this particular L, okay? So we say L. Then we have divide. So we are going to say slash for division, okay? Then G. So already G is graph nodes. We have it, so we're going to say G. So once our formula is done, we put these symbols showing that our formula is done. Now, each and every function, such as the main function, you need to return something such as a 0. So in this case, since we want to return the mean nodal degree, and mean nodal degree is denoted by D, we're going to return D, which will be giving us our expected answer. So the first function has been implemented for mean nodal degree. Now we come to the function for this diameter. So let me just come to see. So as you can see, diameter is equal to max mean nodal degree. So in this case, I won't rush to create this particular formula because we have a lot of mean nodal degrees, but I'll show you when I will do that at the end, okay? So let me just do this. Here we are done, assuming that I'll end here. Then the question says, therefore, necessary data should be passed to the function. The two functions should not return any values. The two functions should not return any values. So if you say these two functions should not return any values, it means these particular functions, you want them to be a void, okay? So a void, you don't expect any values. But in our case, let's answer the question in a way whereby once a user insert all these particular values, we expect to see a certain value. Because if you say the two functions should not return in values, you are telling us that our program should be a void one. Now, I disagree to this because for you to come up with this question, you want to see if a user can really use your program to solve these particular situations. So this last part I won't consider it, but we just make sure that everything is okay. So now here inside the main function we need to consider one thing. So starting off with the mean nodal degree, we'll come to the do while. Okay, so we have variables such as int l, which represent lines. Okay, so we're going to say int lines, okay, because it represents lines. Then comma, we have this variable which is g, which represents graph nodes. We're going to say graph nodes. Okay, now since we have those two variables, we are going now to tell a user, we are going to tell a user after they press 1 what to happen. Okay, so for us to do that we need to use if functions. So if functions, this is how they work. Okay, we say if, so if choice is equal to 1, so we're saying if the choice is equivalent to 1, that's the meaning for equal to, is equivalent to 1, what should happen? So if the choice is equivalent to 1, we want the user to calculate the mean nodal degree. Okay, so we are going to say we are going to tell the user to calculate the mean nodal degree. So for you to calculate the mean nodal degree, you need the number of lines and graph nodes. So I'm going to press the statement which says cout. Okay, cout, we're going to tell the user to enter the number of lines. Okay, why are we telling the user to enter the number of lines? Because for us to calculate the mean nodal degree, we need this number of lines. Okay, so since this number of lines are denoted as lines, we are going to say cin, we are going to link that part with lines, because lines will be stored in this variable called what? Lines. So again we are going to print out another statement which says enter the total number of graph nodes. Okay, so once the user sees this statement saying enter the total number of graph nodes, in this case the number of graph nodes were 6, we need to link it to this variable called graph nodes. So we are going to say cin to accept the input into this variable called graph nodes. Okay, now since these two variables have been entered by the user, they need to be passed into this function for the mean nodal degree. Okay, so what was the name of this particular function, if you can remember? So let me just drag this. So the name of this function was the mean nodal degree. Okay, so if the user passes these things, what should we see? Okay, so we need to expect to see the answer. So we are going to say since this is the mean nodal degree, okay, this is the mean nodal degree, we need to expect the answer. We can say int answer. Okay, int answer. So the answer we expect needs to be in the mean nodal degree function. So if I put a square bracket, you see to say int l, where l are lines. So there I'm going to say lines, then comma, we have g, which is graph nodes. Okay, so I'm going to say graph nodes. So this particular function, this particular formula now will enable these two values to be passed in this function and give us a certain output. So for us to see the output, we need to say cout for us to print out that particular output. Okay, we're going to say cout. So what are we seeing out? So we are going to say mean nodal degree is equal to what? So the mean nodal degree in our case will be equal to the answer, because the answer will give us the meaning nodal degree. So be equal to the answer. Once we do that, we end the line. It means the first part, the first part of the question, which we need to pass this, we implement the function, we are done with the mini nodal degree. Okay, now we come to the part where it says we need to implement what, graph diameter. Now remember, here we need to insert everything which you see. Okay, if you want to do that, so what I suggest is that now inside this thing, we need to put an else statement. So if this statement, if a user presses 1, this will be implemented. Now else if, so else if a user presses 2, we need to calculate the diameter. Okay, so say else choice is equivalent to 2. What should be happening if the choice is equivalent to 2? Remember, we want now the mean nodal degree. So mean nodal degree, it starts with the geodesic distances, as I've said. Now we need an array to capture these things, to store these values. So the first thing I'm going to suggest is that we count the total number of nodes we have. So we have 6 nodes. So we're going to say int, okay, we are going to construct by calling const, then int num nodes. So we have the number of nodes which is equal to 6. So we have the number of nodes which is equal to 6 based on this particular what question. So since we have number of nodes which are equal to 6, we need now to pass these values into an array. So for us to do that, we understand that you're talking about a geodesic distance, but we have their relations first to the distances and their values. So for us to do that, we're going to come up with a string. Okay, so we are going to say string. So this string will help us to save these particular relations, the values, okay, such as n1 and n2 all the way to n5 and n6. So this string are what we call relations. Okay, so we're going to give it a name which is relation. So that relation should be passed to all these 6 nodes, and 6 nodes is what we call num nodes. Okay, is what we call num nodes. So here I'm going to say num num the nodes to represent 6. So if you notice, we are trying to also create these relations, but if you see, the relations are above 6. Okay, so if I count, we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. We have 15 relations. Okay, so if we change this statement, we just say maybe relation. Okay, if we say, let me just name it total. So we have a total of 15 things. Okay, 15 things. So these relations add up to a total of 15. Okay, so these are relations, we want to store them in this string. We'll just put an equal sign, then open and closed curly brace. Okay, so the first thing we need to have here is the first relation. Okay, so this first relation will be added here now. So what I can do to make this look smart, I'll do this. I'll make sure that it's on the same line. Then I'll start now adding the relations. So the first relation we have a relation which is n1 comma n2. So without wasting much of our time, I'll be first n1 and n2. So here we put a comma. Now we come to the next one, which is n1 comma n3 and so on. So let me just do these things quickly. so that I pause the video and you see what's happening. Okay, so I've managed to insert all these relations in this particular string, as you can see from here. Okay, so now since we have these relations, we want also to add these numbers into an array, these values. Okay, so what we need to do here is we now need to create an array. Okay, so this array we are going to create should be an integer. Okay, we are going to say int, then what's the name of the array. So since these are the geodesic distance, I can simply call it geodesic distance. Okay, so that's the array we've created as geodesic distance. Then it has a total number of 15 geodesic distances. So since that value is equal to total, we're going simply to say total. Okay, so now those particular values need to be inserted here. So we have a value such as 0, okay, comma, again we have a 0, okay, comma, we have a 2, okay, comma, we have a 1, so we have 3 ones. So let me just be quick. 1 1 1. We have how many zeros? 1 2 3 4 5 6 6 zeros. Okay, 1 2 3 4 5 6. Okay, then here we have how many ones? 1 2 3. Okay, 1 2 3. Okay, so we have that. So now since that is done, it means we've managed to pass our array. Now remember, here the question, we are interested in to print the diameter. Okay, we are interested in to print the diameter. I can give an example. We need a for loop to perform this particular thing. Okay, so here we can say for, okay, we'll say for int I. So I will be helping us to increment to count the values. So since we have 15 values, we can say for I is equal to 1. Okay, then we say so I can be equal to what? 1, because if we want to count starting at 1 all the way to 15, you can say I is equal to 1, then I is less than or equal to what? This total, because total is that value which we have, which is 15. Okay, so we can now say I plus plus, because we want to increment counting from 1 2 3 4 all the way to 15. So once we do that, we can print out this particular statement to say cout. So for example, we want to print the mini nodal the diameter. Okay, we can say diameter, okay, is equal to what? Now remember, since we are saying diameter is equal to max, okay, it's equal to max geodesic distance. Now this max is the max you are seeing. Now this d and this value, we can simply say d. Okay, now the next value, which is such as I comma j, are these values. Now if you see the value which has this particular diameter is at position number 1 2 3. Now for an array, we don't start counting at 1, we start at 0. So we say 0 1 2. So we consider this as position number 2. Okay, so since it's at position number 2, we are going to see what's the name for this particular thing. It's called the relation, which has this. So we are going to say relation. Okay, so this relation we are seeing is, we are going to say now relation. So that relation, since it's at position number what? Position number 2. This relation is at position number 2. We can simply indicate 2. Okay, but because we want I'm saying 0, 1, 2. So but if we want to print all these geodesic distances, we can just simply say I. Okay, so it will increment each and every value, but in this case I'm simply saying 2 because we want to print out the diameter. So once this relation is done, this relation is this part. Now we have this another equal sign. Okay, so since we have that another equal sign, we are going to say, we give a comment by saying equal. Now this equal sign should be the answer. Now our answer is the geodesic distance. Okay, so the geodesic distance again is at position number 1, 2, 3, which is the largest one to give us the diameter. So for that we'll say geodesic distance. Okay, now the largest one is at position number 2. So since the largest one is at position number 2, here now I can end the line because we are able to display that particular thing. Now I just want to run this particular program for now. So to save it, we can say Control S. Okay, so I want to run this program and see what it will be working or how it will be looking. Okay, so once I do this, now I'll explain the last part. Okay, so here we'll say we'll come to our terminal. Okay, so new terminal. So to run this particular program, we need to make sure that we say G++, the name of this particular file name, which is sessional.cpp, then enter. Then a new file will be created called a.exe. Okay, so we need to run that executable file by saying a, then tab on our keyboard. So once I do this, it's saying press 1 to calculate the mean nodal degree, press 2 to calculate the diameter of the graph, press 3 to exit the program. So that was the meaning at the first part of the question. So this is the mean. Okay, so if I press 1, I want to calculate the mean nodal degree. Now it will ask me enter the number of lines. Remember, on our question the number of lines were 6, so I'm going to say 6. Okay, then enter. So enter the total number of graph nodes. Okay, so enter the total number of graph nodes, again it was 6. Then it will tell me that mean nodal degree is equal to 2. Okay, mean nodal degree is equal to 2. And if we can recall, I managed to solve this manually and the answer was 2, which is correct. Now imagine if you want to calculate the diameter, we'll say 2. Okay, so as you can see now, it's just printing these things like more continuously because it's in a loop telling us the diameter is this, diameter is this, diameter is this, because here, yes, the diameter is 2, I know, but it's doing that because this thing is inside the for loop. No wonder I said if we wanted to print the geodesic distances, okay, we could have said since we want to print the geodesic distances, we can simply remove this part and say geo, okay, desic, then distance, okay, is equal to. Now remember, here we need to press with an I because we're using I, and here again we need to press with an I. Then I'll say Control S to save this project. So here I can just exit the program by saying 3. Okay, so once the program has exited successfully, I can run it again by saying G++, and then that name. So to run this file, I'll run it again like this. So if I say 2 to calculate the diameter of the graph, I'll see that I have the geodesic distances. Okay, everything we had from the question, from 0 to all the way to the last value. So as you can see here, the program makes sense because we can see the geodesic distance. Now how can we find out that this is the diameter? That's where we come in, inserting the formula for the diameter here. Remember, we didn't insert it. Okay, we say int. Okay, we say int So now we are talking about diameter. I'll call it diameter. So this particular diameter has things such as the geodesic distance. That's all. So I'll say int capital letter G for geodesic distance, okay? Int, then capital letter G for geodesic distance. So inside this formula, I will say dia, so int dia, short for diameter. Okay, I can just say int, let me just say dia. Int dia, short for diameter, is equal to what? Since we are saying G, okay, G is just the geodesic distance, the longest geodesic distance. Let me just say int max geo, max geodesic. So I can say max geo. Okay, so now since we have this formula, we can return this dia, because we want to make sure that we have the diameter as our answer. So now, since we've successfully shown the geodesic distances, what we can do now, outside this for loop, we can say see out, okay? Okay, I'll say int answer 2, because this is the answer 2, okay? We had the first answer for the diameter. Now for the geodesic distance, we'll say it's equal to that particular function I'm from creating called diameter. Now inside the diameter, we have this value which is called max geo. Now we don't have a variable which supports the geodesic distance, but we have these things such as geodesic distances, okay? So I'll say geodesic distance, okay? So this geodesic distances is an array. So this particular array, we need to make sure that what's the position for this particular value, which is 2, to give us the diameter. Okay, so if you can see, it's at position 0, 1, 2. Based on an array, we start counting at 0. So I'll say 2. So once this thing is implemented, I'll just put this value, okay? I'll end it like that. Then I'll say see out. So I want to make sure that we print out diameter. So we'll say diameter is equal to what? We are saying max. Okay, we were saying max. Now we come to that particular relation. Okay, max. Now we have that relation. So what's the relation we have in this particular case? So the relation which has this particular guy is at position number 3, if you can remember, or number 2, 1, 2, then 3 is the relation. We have 1, 0, 1, 2, if we are counting from 0. So that's the relation we want. So we are going to say 2, that's the position, okay? So once we are done with the relation, we want to make sure that now we have an equal sign. So that equal sign is going to give us now the answer of the geodesic distance, which is 2, which is answer 2, okay? So here I can end the line. Okay, so once that is done, I'll save the project and try to run it again. Hopefully everything will be okay. So I'll say 3 to exit the program, okay? So let me try to do it again. So we run it. So once I run it, let me go with 2, calculate the diameter. So as you can see, it has managed to intercept all this information for the geodesic distance, and it has managed to say that diameter is max, then this max geodesic distance is 2. Wow. So now I can end my program by saying 3. So let me exit this terminal. As you can see, there is a lot of coding which have taken place, but I'll share this to the group, okay? But what you need to understand is that this is not the only way. I was just trying to make this program look more interesting, but you can do it even the easy way. But I'm not saying I will do it using another way. Yeah. So we are done with question 1. So this was the first part. Hoping I'll be finding more time because we have no time now. School is about to open. Okay. So part 2 will cover question 2. Then the rest of the parts will be going like that. So thanks for watching. This is Soko James representing KMU Cybersecurity Tutorials at Kapasa Makasa University. So as I said, you need to go and watch the playlist which will be attached at the end of this video for you to understand programming, especially in social network analysis. Thank you.